Do you add or subtract volumes of combined solids? Imagine stacking building blocks or carving out a hole in a block. How do you figure out the total space inside? When working with three-dimensional shapes, understanding whether to add or subtract volumes is key. Let's explore how to handle these calculations smoothly. When two or more solids are joined together without overlapping or cutting into each other, you simply add their volumes. Think of stacking a cone on top of a cylinder. To find the total space inside, calculate each shape's volume separately and then add those numbers together. This method works because the shapes are just combined, not cutting into each other. But what if you have a solid with a hole or cavity? For example, imagine a cylinder with a smaller cylinder drilled through the middle. To find the total volume, you start with the large cylinder's volume and then subtract the smaller cylinder's volume that makes the hole. This subtraction accounts for the empty space inside the solid. So the main idea is to look at how the shapes are combined. If they are joined without overlapping, add their volumes. If one shape is cut out of another, subtract the smaller volume from the larger one. Now, how do you do the actual calculations? First, identify the basic shapes involved, like prisms, cylinders, cones, or spheres. Then, find each shape's volume using the right formula. For example, a rectangular prism's volume is length times width times height. A cylinder's volume is pi times radius squared times height. A cone's volume is 1/3 pi times radius squared times height. Once you have these numbers, decide whether to add or subtract based on how the shapes are combined. If they are connected side by side, add the volumes. If one shape is carved out or hollowed out, subtract the smaller volume from the larger one. This approach helps you solve many real-world problems. For instance, calculating the volume of a swimming pool with a deep end involves adding the volumes of different sections. Or finding the amount of material needed for a hollow pipe involves subtracting the inner hollow volume from the outer cylinder. By breaking complex shapes into simple parts and carefully choosing to add or subtract, you can find the total volume accurately. This method makes understanding three-dimensional shapes much easier and practical for everyday tasks.